Bismillahirrahmanirrahim. This video is from Mr. Hayt's book, and here we'll be discussing practice problem 14.1, and this is related to complex frequency. So straight away to the question, identify all the complex frequencies present in these real functions. So these are the functions given, and in this we have to identify the complex frequencies. And before we start, let's have some theoretical background. And that any function of this type may be written in the form of a k constant e raised to the power st. So this is the Laplace form, and this k is constant independent of time, whereas s is the complex frequency. And this can be represented as the real part and imaginary part, the sigma plus minus j omega. So this is what we need to find, and this can also be written like if we put value of s, this one, then it will be e raised to the power sigma plus j omega into t. What we need to find is this term without t in all these questions that we'll be solving. The first question, these two terms are in the form of a e, power of e. So we have to convert sine into power of e as well. So that will take Euler's formula as help. And for sine function, the exponential form is ejx minus e minus jx divided by 2j. So we'll use this form. So this remains as it is, multiplied by, for the sine we are writing now, this value 1 over 2j from here, and e raised to the power plus j 2000 and e raised to the power minus j 2000. And then we'll simply multiply and add the powers. We're multiplying, or we're taking this outside, and then we multiply this with this, and similarly second term, the last term, and multiplying or writing each term together. And then we know that the powers can be added. So adding the power, now this is the final form, and from here we can extract the value without t. So this is the complex frequency. Like we saw here, e raised to the power, this part is complex frequency. So from the above, the complex frequencies are this one, minus 100 plus j20. Similarly, the second one, the third one, and the fourth one. And the book also has same answer, except that he has added per second, or s power -1. So we know that the frequencies are in per second, cycles per second. So that is why we should write this as well. The second question, or part B of the question, we have now cosine, and we'll use the same technique. From the Euler formula, we'll now use this formula. So writing for cosine, then multiplying first term this and the second term. Further simplifying, this will become 1, and this is half e raised to the power minus 10t, and multiplied by these terms. We have just opened the bracket here. So the internal sign has changed to negative. Now this have nothing to multiply, so we'll keep them as it is. These two are now will be multiplied, that is power added. So the power is added in both these cases. We rearrange this, open this bracket, take t common from here. So the term associated with t is the complex frequency. Just like in the previous case, this was associated with t, so this was the complex frequency. Same here. we will not consider phi here because e raised to the power phi will be some constant value. We are only concerned with this value. So from here we can write the answer. In the first case it will be J4, then minus J4, then this term minus 10 J4, and similarly minus 10 minus J4. And the book answer is also similar except that he has written per second. So we should also write it per second. Third part is the multiplication of cosine and sine. Here also we have to use the trigonometric formula. We'll first solve this part. And we know the formula for cos A sine B. So this is the formula, so we'll use this formula. So 10 and 40, so 10t plus 40t and 10t minus 40t. Simplifying, it will be sine 50 and this one will be minus sine minus 30. And now we'll convert these with the Euler formula into exponential form. So just following this is for the first part and this is for the second part from this formula. We simplify, open it. And now we go to the main question. So this question e raised to the power minus 10t. And for this term, we have got this value here. So we'll plug in. And now we'll multiply each term. So multiplying, this is the value or this is the shape. We can take t common. We've taken t common. And now easily you can identify this to be the complex frequency. So the complex frequency is minus 10 J50, then minus 10 minus J50, and similarly the second term and the third term. So the book answer is also similar except that he has written the 30 terms first, minus 10 J30, then the second one, then third one, and the fourth one. So I hope you have been able to follow this. Please let me know through your comments. Thank you.